Okay. Can everybody see my screen okay? Looks good. Okay. Well, thank you, Amanda, for that introduction. Thank you, Paul and Amanda, for the opportunity to share some of my knowledge about using R. My name is Matthew Pastizzo. Feel free to call me Matt. And I love to consult. I love data. So if any time you're working on a project and you get stuck, please feel free to reach out to me. I always enjoy a challenge of looking at new data. I've used R for about 10 years now, and I still make mistakes. So that's something I'd like to tell you, right off the bat. You will make mistakes when you're typing. That's okay. The key is to stick with it. There are a handful of commands that we'll learn. With a few dozen functions, you really can do quite a lot in R. And so really it's a question of the patience to learn those functions and to be patient, work through them. And then I think you'll find that you can be very efficient, very productive in making sense out of data. So one more thing to share. My passion for R earned me a paper plate award at one point, most likely to use R on a Friday night. So I suppose I should be embarrassed to admit that. I have R open on my computer all the time. It's something that I use quite a lot. And so as I'm talking here, in case you still need to install the software, you actually can do this very quickly. So I'm just going to leave this page up. I'm only going to talk for just a couple more minutes before we jump in. But this will give you an opportunity, last minute opportunity to download and install R and R Studio if you need to. So R Studio is on my desktop. It's open all the time. I might use it as a calculator, right? In the command console, I might just need to check out what's 1200 divided by 5. Chris or someone else could quickly tell us the answer. But the idea is that this really is an environment to do a lot of things, from automatically going through 100 Excel files and many more, which I did for our CDWG project, the tagging project. I did all of that in R, or I just use it as a calculator, or I use it to help me grade exams. I use it in teaching. I use it in research. I use it in the department. A lot of times we'll have discussions and inevitably there's some tension about a topic and we resort to speculation. Well, I think this, I think that. And what I've started to do is bring R in and say, okay, well, we have the data. Let's look at the data. And so R is just a really great environment to interact with, to explore data. It goes beyond having preset analyses. It's about, okay, I have this big data file. Somebody emailed it to me or I found it online. Now, how do I make sense of it? How do I start to play with the data? How do I explore it? So it's very much an interactive process. And I'll start on script with the GitHub page and then maybe go off script a little bit so that you can get a feel for the experience. Feel free to stop me at any point. Maybe throw a question in the chat if you have any questions. One of the first things I asked you to do was to install some packages. That's something that you can do now if you need to. So we can do that in a few ways in RStudio. We can type the command at the console prompt, or we can use the graphical user interface. So I just wanted to point out to you before we get too far along that the console is where we're doing all of our work. So here's where I can type 2 plus 2. Here's where I can make a new variable called x with a few values. Okay, everything happens at the console. I can also optionally type all my commands into a text file. So if I say 33 times 5 and click run, that sends it over to the console. So I just want to point out the console is the heart of the operation. This is where R resides within RStudio. So RStudio is just an environment that allows us to stay organized. One thing that's handy when you're in the console is pressing Control L. That'll clear the console. But the commands that you typed previously are still accessible if you use your up and down arrow. So if you've attended Paul's workshops on the command line, that'll be familiar. That's just like using a terminal on a Mac or a Linux computer. Okay. So in terms of installing packages, the one package that I'd like to make sure that you all have is the PLYR package and case matters. Now it's giving me an error message because I already have it loaded in memory. If you don't have it, it would just go ahead and install it for you. If I go down here to packages, I can show you that the PLYR library is already installed. And if I uncheck this, okay, what I've done is I've detached it. So now if I wanted to install, it should let me do that. Okay, of course, because I'm presenting, it's going to give me an error. That's the curse. That's the curse of presenting. The other way to install packages is to simply click install here and type the package name. Okay, so either way. All right, and it wants me to restart. That's going to bug me. Paul can relate. You went through something similar recently. All right, so at any rate, that's just kind of a quick overview of our environment. I'm excited to dig in and use the actual data that I prepared for today so we can start to play a little bit. So I'm just going to clean things up. Notice that we do have some GUI tools, like a little broom we can click on to clean things up. There also are commands for all of that. So let's start by importing the data. Right, we need some data. And I shared with Paul and Amanda, I was struggling with what kind of data to choose, right? What would be most interesting for all of you? There are so many choices. I decided to go with the language example, something that's near and dear to me, psychology of language. And so I thought that we would look at double negatives from a 1.6 million word spoken corpus from the University of Michigan. I wrote a separate program that went through and counted how often various phrases occurred, like don't worry, don't panic, don't hesitate, things like that. The idea is that if we tell somebody don't hesitate, we're trying to encourage them, yet we're doing it in a negative way. So that negative framing is very interesting to me for a variety of reasons, and I could spend an hour just talking about that, but we need to stay on track here. So if you're using the GitHub page, you could copy and paste the code here, and that would import the data. My hope is that you've already downloaded the phrases and negations file. So the first step, going back in the software setup, the first step was to install RStudio and then to download those two files. I have them saved to my desktop. Okay, so where I'd like to jump in is on this fourth step, validating the data, which assumes that we have the data. So let's take a couple minutes and make sure that everybody can get the data. If you've already downloaded the data, you can check your current working directory, git wd, and then parentheses, we leave them empty, will tell us the current working directory. If we needed to change the working directory, we could say set working directory, and then once you start to type, you can use your tab key to set your directory. Okay. Now, what I just did was I set the working directory to where I already am, but I wanted to illustrate how you can use those two commands. If you're not quite sure where you save the files, that's okay. You don't have to navigate to the directory. So we have three different ways to do this. You can navigate to the directory as I just showed you. You can use the URLs that are the full URLs to the data file are included in the GitHub page, or we can use a file chooser. So let's start. We're going to make a new data frame called phrases. And I think to simplify things, let's just call it P. So it's less typing. So this will be the first thing for us to all do together. Let's say P equals, and the phrases data file is a CSV, comma separated values file. So we're going to say read.csv. Notice that in this environment, as we start to type, it makes suggestions for us. So we can use, as we type, we can press the tab key, and that'll use tab completion. And then if I don't know where the file is, I can use another command, file choose, within that function. And what that'll do is that'll pop up a file chooser. On a Windows computer, you'll have to look at the bottom of your screen where there should now be two R icons, and one of those R icons will be this navigation window. And that would let you pick, we want phrases.csv. Okay. So that's one approach. And I'm going to pause because I'd like to at least see that everybody who's set up with R is able to do that. While you're trying that, I'll just put up an alternative. Because I'm in the correct working directory, I can also just do it that way. So if you're in the correct working directory, you can just type the file name. Okay, so either way. And then the third approach is, if all else fails, go to the GitHub page. I think, Amanda, did you put the link in? I think Amanda put the link in. So if you're on the fourth lesson, validating data, you can copy and paste that phrases right here, and it'll take it a moment. Oh, I see what I did. I now have two objects. I've got one called P and the other one's called phrases. Notice in our environment tab, they're both identical. In fact, we could do something. Here's where I'm going off script. We could say P equals phrases. That's asking, is it equal? Two equal signs means, is it equal? True. Lots of trues. Okay. So just to go back, you can either use the file.choose, you can use the read.csv, or I'll modify this. We can use the URL. All right, I'll just wait a second to see if anybody in chat has a question. And by the way, I'm going to remove. So RM is for remove. I'm going to remove phrases, and watch the bottom left. I just deleted the phrases object. So now I just have the P object. So I'm just kind of looking at the screens to see if I can tell. Has anybody had success? Can I have any thumbs up? All right, I'm seeing Charlie's got it. All right, good. Thumbs up, excellent. All right, so here's where R is a little unsettling for folks who are used to a different statistical program or using Excel, because we don't see the data. Here's where we have, to borrow a phrase Paul used the other day, silent success. So how do we know it worked? Well, we can see the object in the bottom left, but we can start to ask questions about the data. Okay, so for example, we can say, what are the dimensions of that? We're going to get 4,061 rows, 4 columns. Well, we can see that in the bottom left. So here's where RStudio spoils us a little bit by giving us some of that information. I'll be honest with you. I don't look at the environment tab anymore. Everything I do is just asking at the command line. Okay. What about names? What are the variable names? This gives us the variable names. So part of learning R is figuring out the names of the functions. In this case, in these cases, dim is short for dimensions. Names allows us to find the variable names. As my students have discovered, you can also use variable names. Okay, you try it. you do Google search, you try it, and sometimes things don't work. So you might try names, and I have no idea what's going to happen. Oh, it can't find it because it's not a function that R has built in. What if I really like that? Well, here's the flexibility of R. R is fast, it's free, and it's flexible. Suppose I really like names with an uppercase. I'm just going to make it equal to the other names. So what I've done is I've copied the function. I made a copy, I made a clone of the function. So slightly off track, but I just want to show you the flexibility of using R. Okay, so I'm just going to clean up that names that I created. So at this point, all we have is the one data frame P, and here's a peek at the top 6 rows. So I just used the head function. Note that everything is case sensitive. Spaces are tolerated. So this is goofy, but you could just as well have a bunch of spaces. Okay, so R is case sensitive, but it ignores spaces. If we want to see the bottom, this shows us the last 6 rows. So head and tail are useful. C1 is for the first constituent of the phrase, C2 is the second constituent, and then we have the phrase itself, and then we have the frequency, how often that phrase occurred in the 1.6 million word corpus. If we really want to see the data, we really want to look, we can try view. I'm purposely making a mistake here. View has an uppercase V. And when you do that, what happens is it opens a spreadsheet view of the data. Now, part of what I like about R is it's an environment to interact with the data, to think about the data, to ask questions, to get responses. There's a temptation to look at data. But even here with 4,000 rows, I really don't want to scroll through 4,000 rows. And if I had 20,000 rows, I certainly don't want to scroll through 20,000 rows. And if I have 40 variables, I don't want to scroll through 40 variables. So it's very much an environment of thinking about what do we expect and do the data fit with what we expect. Okay, so at the moment we have in our environment, so you can use ls to see what's in your environment. That lists what's there. We have one object P, and we can check the structure of it. It's a data frame, 4,061 observations, 4 variables. Now I'd like us to install the second data frame so that we can do some more work. So going back to the GitHub page, I'm going to take this negations line. This is the second data file, and I'm going to copy and paste here. But I actually would like to just call it N, just to make it a little bit shorter. Now you may get an error there. You do need to have the open XLSX library installed. So that was one of the packages. The open XLSX library is a library of functions that allow us to interact with Excel data. So the read.xlsx function is a function that comes with that open XLSX library. What's really great about the R community is it's a community of researchers, academics who love data analysis, and will often contribute and make libraries of functions freely available for us to download and use. Whether we're looking at fMRI data, we're looking at genome sequencing. I'm trying to think of something that would be done in biology. So we can do text analysis. So we can make word clouds. I mean, it's just a question of finding the library, the package, and library are used synonymously. So it's the package or library of functions that somebody or some group of individuals made for us to let us get some work done. If we need help on a function, you can type question mark, read dot, and what in this case, it's read.xlsx. And here we open up the help tab, right? And that gives us information about how to use the function. So this is a really great way to learn R. So if I look at this and I say, oh, neat, I can say which sheet. Maybe I want to import sheet 3 from my Excel file. Or I can say, oh, no, I don't want the column names. The default is to say true. If I change it to false at the time I use the function, then it will not take in the column names. And so this is really a great way to explore how to use the functionality of these functions. The arguments or parameters are each described individually. If you really get into using R, something we did with my advanced R class, we make our own functions, and R Studio will let you make your own package and publish your own package of functions. So you can have quite a lot of fun doing that. And it's really easy. Okay, R Studio makes it really easy. All right, so we'll stay focused here. We should have 2 objects. We have 2 data files. So we already looked at the first, I'm going to say just the first 3 rows. Okay, the second argument of the head function is the number. So I can either declare n equals 3, or I can just say 3 if it's the second argument. Okay, and then we can look at the first 3 rows of the second file. So here's what I did. I took the 1.6 million words that are in a text file, and I went through and I found all the versions of not. So not, and then the contraction versions. And I'll need Paul to correct me if I make a mistake with the English terminology. But so you've got not, and then you have all the contraction forms. And so I made 2 separate files, one that counted simply how often those contracted forms occurred by themselves. And then the other file shows how often they occurred with a second constituent to make a phrase. If we're curious, we might want to take a peek at the end data frame. So let's see if we can do a sorted version of, here, we'll do view of n. We'll lean on the graphical user interface for just a moment. Sometimes I'll do this. It's a quick way for me to click here and sort. So even though this is a good example of how I could have typed code that would give me a sorted version. But in this case, it's actually faster to just lean on the spreadsheet view and use the built-in filter. So I'm definitely not above using the graphical user interface if it's going to make it quicker. All right. There are other cases where it's better to type the code. So here we can see that not is the most frequent, don't the second most frequent. Just for fun, we can look at P as well. And so we can look at the most frequent phrase, don't know. Not surprising. So in conversations that were recorded at the University of Michigan for this 1.6 million word corpus, the most frequent phrase involving a negation was don't know. Okay. And then we can look for things. We can even use the filter here to look for things like worry. Don't worry. Occurred 40 times. Don't panic. This is starting to sound like my office hours. How about this? Stats. Don't cry. All right. From a psychology of language perspective, I'm actually interested in finding out if this negative framing is more harmful. So saying don't worry, are we reminding the person that they're worried? Would it be better to say, hang in there, you'll get through this? So would positive framing be better? And so if you're about to cry or panic about R, hang in there. We'll get there. So our studio is this really beautiful environment. I found out about this from a biology student. So I was using just R, and a biology student who was in my stats class said, oh, do you know about R Studio? This was a number of years ago. I said, oh no, what's R Studio? You know, I thought I knew everything already about R. He's like, oh, check it out. So I did, and I've never gone back. R Studio is just a great way to work with our data. Okay, so let's try to do some practical things here. I'd like to rename variables so that we can merge. Instead of trying to go through all the code in GitHub, what I thought I would do is walk you through this in a live session together, and then you could always go back to GitHub and try the individual steps. So let's look at our two data files, and I'd like to merge them. But before I can merge them into a single data frame, I need the variable names to match up. So notice that C1 is the variable name for the first constituent in this first data frame P, but then version is the variable name that's used in the second data frame. So to fix this, this is really cool. I think you'll like this. If we say names of P, names of N, that gives us the variable names. If we use square brackets after and we specify the number, that's going to isolate that one variable name. So the square brackets are very powerful. It's a subsetting function. So this tells us what the name is. We can take that same function. I love this trick. We can take that same function and just set it equal to something else. So we can actually change. We can now change what that variable name is. Here's silent success, we hope. Let's confirm. Let's confirm. Now let's check and take a peek at that data frame. Notice up here, data frame N that contains our negations and their frequencies, the first variable was named version. We renamed it to C1. So now we have a variable name in common between these two data frames. Data frame P has a variable C1, data frame N has a variable C1. I use this a lot when I'm working with department data. I'll take Argos data, I'll have student data with a G number and email address, and then a separate file with a student's G number and the courses they've taken. The G number is the common key. Having that same variable, I can then combine the two. So if I filter based on students that still need to complete a seminar, right, then I have their email addresses and I can email them. Okay, so that's sort of another application that I'll use R for. Course and research, yeah.
Just to jump in here, so it looks like a difference between R and Python is that if you've got a list of items, the first item is assigned the number 1, not the number 0, which is people may have to get used to.
Yep, that's a great point. So in programming languages in general, they're pretty similar, but then you get small differences. So in one language, you might have a single ampersand for and, the logical and. In another language, you might have 2 ampersands. Some start an array or list with 0, some start with 1. So yeah, thank you for pointing that out. So the next thing to do is before we merge these, I'd like to deal with the fact that they both have a variable name in common. So when we merge them, we really don't want 2 variables with the same name. It turns out the merge function will fix that for us, but we can control it by changing the names ahead of time. So I just press Control L just to just to clean things up. So just to remind us, here's what we have so far. I'm just looking at the first line in each of these. And so I'm going to change, we're going to take the names of the P data frame that has our phrases. We're going to take the fourth variable. So 1, 2, 3, 4. And before we change it, let's make sure it's the right one. Now I'll use my up arrow, save some typing, and I'll set it equal to, we'll make it we'll make it equal to, let's say, phrase underscore frequency. And so now we've changed that variable name. So when we get to merging, we'll have a clear distinction between the two frequencies. In the second data frame N that has just the negations and their frequency, we'll change that variable name as well. And so we'll say names of, I like to say of with parentheses when I'm talking. So names of, I'm saying the names of this object. So the object N. And then we'll subscript this 2 just to make sure that's our frequency. That's our second variable name. And we're going to make that equal to, let's say, negation underscore frequency. And if we just take a peek, we can see that we've successfully renamed that variable. I'm just going to pause for a moment. Just to, if you're feeling, I'm not sure if I'm going too fast or too slow, part of this takes practice with typing. And I hope if nothing else, I hope that this workshop inspires you to start playing with R. There really are only a few dozen commands that do a tremendous amount. So once you know dim, str, ls, remove, names, head, tail, there aren't that many of them. Okay. It's a fairly short list. So hang in there. Okay. So at this point, let's see if we can do some merging. We're just going to check one more time the names of P and the names of N. So we see that we can merge by C1, and we see that all the other variable names are distinct. And if we check the dimensions of each of these, what we expect when we merge these is we expect that we're going to have 4 columns from P and 2 columns from N. So we'll have 6 columns when they're merged, except one of them is in common. So we'll actually have 5. Instead of 6 columns, we'll have 5 columns in the merged data set. So our goal is to create a new data frame that I like to call D. D is my favorite name for a data frame. I just call it D. I call everything D. For today, I created P and N just to make it a little bit more transparent, but I call everything D. It's so much easier to type. But you could, in terms of naming, you could say, you know, that awesome data frame 2, 3. I mean, you can come up with a bizarre name, anything you like, as long as it starts with the letter. So we're going to make a new data frame D that's going to be equal to the combined or merged results. Before we merge, though, let's see what the merge will look like. So here we're going to use function embedding. I love function embedding, taking the results of one function and feeding it to another function. It's like using a pipe in the terminal where you send one thing to the next to the next. So if we say head of the merge of P comma N, and if we wanted help, we could look up help on merge. So we could find out how the merge function works. So this is the base merge package. So we're going to merge 2 data frames. And the default method is just to specify them. But then we have some other things that we can modify. So let's just start with this and let's see what happens. So this looks pretty good. What we're doing is we're seeing what it would look like if we did merge them. We're just seeing what it would look like. So we haven't committed yet. And if I change this to dim, now we can get the dimensions of what we would get when we merge them. So we can check to see. And I've noticed that there's a problem here. So the dimensions of our merged object are 4,031 rows and 5 columns. The 5 columns I'm okay with. 1, 2, 3, 4, 5 columns, because we had 4 in one and 2 in the other, 6 columns, but there's 1 in common. So there are only 5 unique columns. We've lost 30 rows. What happened? That NA is ominous. There's always something going on with NAs. We've got missing data. There's missing data. So when we do the merger, right? So we'll just check this. We'll check the dimensions of this, but we're going to modify the merge function. So I'm going to put a third argument. The way I did that is I put a comma after the N. So P comma N, now comma. And now I hit the tab key. This is great. Tab shows me my choices, just in case I forgot what they are. And I want by X. No, I don't want by X. I want all X. I want all the X values. And do you see here where it says, I can't point to it because I'll lose it. Oh, maybe I can. See how it says the default is false? So by default, it's not going to give all X values. X is the first data frame, P. Well, we want to override that. We'll say it's true. And when we do that, we retain all 4,061 rows, including the ones that had NAs. Okay. Something to point out here is that the case matters. The dreaded red font. Okay. How many of you, I won't ask you to raise your hand, but some of you have seen red on your screen during this workshop. And others, me too, right? Chris, yes. So a lot of this is debugging, right? And so if you're ever reaching out to me or someone else for help, just copy and paste your code with the error, email me or email someone else, and we can help you to debug it, okay? This is not a very descriptive error message. This is going to be hard to debug, all right? So it's one of those things where you just need to know that logical T or true has to be uppercase. Okay. Now, one nice thing about R is that's true throughout all of R. So even contributors have adhered to that. So an uppercase T or uppercase F is always going to get the job done. All right, so let's commit. Let's commit to this merge. We'll commit to the merger. Let's make the new data frame D equal to what we get when we merge those two data frames, saying all dot X equals true. You can type all of true or just the T. And when you get further along using R, there are other shortcuts. All.x is called an argument name. Sometimes you can just abbreviate the argument name. Okay, but you'll learn that stuff as you go along. So now we can take a peek at our new data frame D. We're seeing a bunch of NAs, which I really don't like. So we're going to get rid of them. And you might say, well, you just said to keep them. Why are we going to get rid of them? Well, in terms of the workflow, when I'm merging, I want to make sure everything's there. Let's make sure everything's there. Let's look at it and then make the decision about whether or not to delete it. I'm confident that I don't want these NAs. There are cases where there was a missing constituent, and I don't want cases where there's a missing constituent for this analysis. So how do we find these? here's something new. I'm going to make this a little bit bigger here. Here's something new. I'd like us to look at data frame D, but just part of it. So we're going to use the square brackets again, kind of like we did for the names function. So we're going to just look at part of data frame D, not all 4,061 rows. But I can't just give a single number here because we have two dimensions. The names was a single list. So we had the first variable name, second variable name. That's just one dimension. A data frame has two dimensions, columns and rows. So we actually need to specify two dimensions. And in R, it's always rows, comma, columns. So if we say 1, comma, 1, this is like Battleship now. First row, first column, which was a blank value. If we want the 100th row, first column, it happens to be aren't. If we want just to see what's on the 100th row, that's what's on the 100th row. If we want to see what's on the last row, that's the last row. Okay. So what I'd like us to do is use this subsetting to find out about those NAs. So here's where if we say nothing, then there are no restrictions, then this is the entire data frame. That's the entire data frame. So if we just do this, I get the whole thing. That's more than I want to look at on the screen. Okay, so we need to restrict it. So if I want to restrict rows, I could take the rows 1 through 6, which by the way is identical to head of D. Okay, this is so powerful, this subsetting function. So then we can get to be a little bit more sophisticated. We could say, let's look at cases only where we're going to, I don't want to get too far ahead. We're going to look at cases where the frequency is very high. Well, to do that, we're going to put a restriction on rows. We only want those rows where the frequency is high. The way to point to a variable name, is going to be with a $ convention. So if I say D dollar phrase frequency, that's my pointer. The $ points to that variable. So that's just all the frequencies, D $. So if I combine these two, right? If I want a subset, I only want to look at those rows where the D $ phrase frequency is greater than 500. That's going to only give me the rows in the table that have greater than 500. Okay, and I get the don't know, don't think, don't have. The only thing that's muddying the waters are these NAs. So let's clear the NAs out. And we're going to do that with the subsetting function. So the way to do that is to simply say that we only want the rows where we have complete cases, meaning no missing values, a double negative, apropos for the type of data, right? So we're going to keep the ones that do not have missing data. So if I check the dimensions of that, it should be something less than 4061. And it is. There actually are 45 rows. So 4016 plus 45 gets us up to the 4061. There are actually 45 rows that have missing data. There were 30 rows with missing data in P, and there were 15 with missing data in N. Together, 45 missing rows. Notice that I'm checking on things before I commit to anything. Now I feel confident that I can, and this is risky, be careful before you press enter. Now I'm going to make data frame D equal to a modified version of itself. So if I mess this up, I then have to go back and remerge the data. That's why I did this command first, so I could check on the anticipated output. Okay, oh, we locked it in. I locked it in. So dim of D, there it is. We take a peek. Okay, things look good. Okay, so I've gotten rid of. If I had put an exclamation point before complete, that's the opposite. So exclamation point does the opposite. All right, that just negates whatever I ask for. So now if I look for the frequency, oh, that looks much better. Now I can see those with the highest frequency. And maybe I want to look at, a lower threshold. Okay. So there's so much that can be done. I'd like to just give you a sense of some of the ways that we can aggregate and visualize. I got to be careful though because of time. So let's do a quick visualization, and then maybe if we have time, we'll do aggregation. All the steps, a lot more than what I've done here today, are all on the GitHub page. So if you go through them, I think you could probably do the whole thing in half an hour or so, maybe an hour. Okay. And you'll get a lot more exposure. Let's plot something here. So let's suppose that we want to look at the phrase frequency. And so I'm just going to type that in there, hit enter, and it's giving me an error message because it won't fit. I first need to make sure I have space on my screen. So now it'll fit. That's not a very appealing plot. So let's go off script here a little. Let's make a new variable called FRQ. We'll just make a new variable and we'll make it equal to a subset of the data frame where D $phrase frequency is greater than, let's say greater than 5. Okay, and we only want, we really only want the frequency, which was the last column. So that was column 5. Now, how do I know that? Well, you could check names of D, 1, 2, 3, 4, 5. It's the 5th one. Okay, and then if I take a peek at FRQ, it's going to give me all the frequencies, but only those that are a frequency greater than 5. Okay, and there they are. Okay, so if we now plot that new variable, we get something slightly more informative. Sorting that looks even better. I embedded the sort function within that. Or we can make a box plot. Okay. I realize I'm buzzing along just a little bit. I wanted to just kind of show you some of what can be done. I put a lot more care and thought into the GitHub pages and step-by-step. I have much better visualizations, better labels, all of that, more sensible, creating new variables, all of that. Part of what I wanted to do while we're live together is have you see how, how at least I work with R and asking questions, making changes, making new data frames, subsetting, filtering, aggregating, etc. In terms of aggregation, if I wanted to compute the average frequency for each of the types, I need that PLYR library, which is going to give me red again because we're in a live session, not if I'm doing this on my own. I already have it loaded. If I use the ddply function, which is part of that PLYR library, ply is neat. Ply means to fold. So it's like folding the data. It's an aggregation. And if I specify the variable that we want to fold by, and again, this is all in the GitHub pages. If I want to compute the mean, which would be the mean of the phrase frequency, what I've just done is I've computed the average frequency of occurrence for each phrase based on the first constituent. And so I find that don't has the highest average. If I wanted to do one more thing here real quickly, I could also ask for the number of items. So I can do multiple things. I can say n is the length of how many items there are. And so what this does is it tells me the most phrases. There are 1,489 phrases that start with not. The second highest are phrases that start with don't. And then this gives me the average frequency of the phrases within each of those group. I could aggregate by more than one thing. So I only aggregated by C1. You can comma delimit, specify as many things. So thinking about if we had a length variable, well, let's see. What else would we have here that's meaningful? So, well, I suppose we could, yeah, it wouldn't make sense to aggregate. Well, I guess we could try to aggregate by C1 and C2. It's going to be a large, it's going to produce quite a lot. So here we see can't with each of the second constituents. So like can't get is much higher in frequency than say can't force or can't fix. Okay. One more cool trick. If you have library, again, I'm hoping this will just pique your interest. If you have the Clipper library, this is a good red. This says welcome. If you have the Clipper library, there's a write underscore clip. This will write to your clipboard. So if I take this and I say write underscore clip, what that's going to do is it's going to take, instead of putting it to the screen, I just copied it to my clipboard. So I do still depend on Excel, right? I still will, I'll do something in R, I'll get it the way I want it in R, and then I'll open Excel and I can just copy and paste right into Excel. And now I have that right in Excel. I can save this in Excel as Excel or CSV, and then I can re-import. I can make changes. I can re-import into R. And so the cycle continues ad infinitum. All right. I hope that was useful. Hope that's helpful.
That's a great stopping point, Matt. Thanks.